The next problem is called maximal flow problem, where we have a network and the network has one single source point, then one single destination point. It's called source and sink. And then in between, there are lots of nodes and arcs. So each arc has a capacity. The goal of this model is to figure out what is the maximum amount of flow that can be sent from the source to the sink. So one example would be, suppose if you have a network of highways from one city to the one part of the city to the other part of the city. So how many cars at the peak, at the maximum number of cars that can go from one place to the other? Or if you have a pipeline, so what is the maximum amount of product that can flow through the pipeline if you have a network of pipeline? Okay, so here is an example. Say it's a road network, and then we have the west point and the east point. Okay, so now we have each arc, each node has an arc, and there is a number associated on either side of the arc. So that means this number means there is at the maximum you can send 3 units. So here I think it's in thousands. So 3,000 cars can go in this direction, then 1,000 cars can go in this direction. Okay, so 2,000 cars and 0. Apparently this is a one-way street. Okay, so the number is the capacity, the maximum that can flow from one side to the other. Okay, and the problem is maximum flow. What is the maximum number of cars that can flow from here to here? Okay, and you can set this up as a linear programming problem. Okay, so this is what the linear programming problem will look like, but we're going to set this up in Excel. Okay, first thing to do is to enter all the capacities. Okay, so from each node to the other node, what is the arc capacity? So these are the capacities. These are translated from here. So 1 to 2, 1 to 4, and 1 to 3. It will be 3, 10, and 2. So 1 through 6, 1 through 6 are the nodes, and each cell represents an arc. So all of these numbers are now entered here. Okay, so let's do the borders and color code. Okay, so this is the from node, to node, and each of the arcs. Okay, so now each of the arc, the origin and the destination, okay, must be set up. So from 1 you have 2, 3, and 4. Then from 2 you have 1, 4, and 6. Then from 3, so from 3 you have 1, 4, and 5, but 1 is 0, so we can omit 1, 4, and 5. So 3 to 4 and 5. And then we have 4. So 4 to, so that's 0, we can omit that. 4 to 2, 3, and 6. 2, 3, and 6. Then we have 5. So 5, we have 3 and 6. And for 6 we have 2 and 4. Okay. So now we need the capacities for each of those arcs, and since these are in numbers, okay, we can use index without having to use match. So index the array should be absolute referenced, comma origin, and destination is the column. Origin is the row, destination is the column. So then copy that, and you have the capacities. And so now we need to add one more arc that's actually not here, and that's what will measure how many cars are going out. So you need what is coming into 1 should go out of 6. That's what will determine what is the maximum number of cars that can flow through. So we need to make sure that 6 to 1, okay, what is coming in from 6 to coming into 1 is equal to what is going out of 1. So we need a flow which actually is not taking place, but this is for the purpose of figuring out how many cars are successfully leaving node 6 that have entered in node 1. Okay, so that is our changing cells. Okay, and the flow has to stay within capacity, okay, for each of the valid arcs. Okay, and 6 to 1 there is no capacity. That's what we're trying to figure out. Okay, and that is our objective function. We want to maximize the flow going from 6 to 1, the imaginary flow that is going from 6 to 1. So we can set that equal to that cell. Okay, and that's what needs to be maximized. All right, and the constraints are the cars coming into a node should get out of that node, right? So we have 1 through 6 nodes. Okay, so net flow is sum if okay, so sum if the range, okay, if 1 is the destination, so that's our destination. Okay, press F4, comma the criterion, okay, comma the flow, and press F4. So that's going to give us, this sum if will give us, since the node 1 is used as the destination, that's going to give us how many cars are coming into 1 minus sum if, okay, now use the same node with the origin. So that origin is the range for the if, F4, comma node criterion, comma the flow is to be sum that should be absolute referenced. All right, copy that, and that should be equal to 0. So what's coming in should go out. Alright, so now solver, we want that flow going out of node 6. We want to maximize that. So this is the flow. Add the net flow must be equal to 0. Then we have to make sure that the flows, the actual flows from 1 through 6, okay, less than or equal to the arc capacity. And then non-negative, simplex LP, and solve. So maximum is 5,000 cars, and these are the flows that will take place.